Hi, I'm Sam Lilly, SkreetKar 3D. Today I'm going to be demoing the new Revopoint Metro Y Pro, the new laser scanner from Revopoint. This was actually just released. It's actually starting to ship to multiple people that pre-ordered the device. But I'm going to be demoing it to scan a modular GT500 oil pump casing. As you see in this camera right here, this is the case half that has been removed. So I have the gear set removed and the back plate. So you can see the internal crevices and whatnot. So I'm going to be able to try to scan this. And what I'm using is just my turntable. And I'm going to be trying to elevate it just enough that I can hopefully get underneath it. Have a nice plane that I can cut off. So we shouldn't have to do more than 2 scans to do this. So as you see, I have Revopoint Revel Metro 5.8 running right now. I'm going to go ahead and kick this um, because it's a smaller part. I'm going to go ahead and try to use parallel line mode. I think that's going to get us to our target as crisp and sharp as possible. Now, I personally always like to use either shiny objects or black object. Just me personally, I like the black object mode. I think it just picks up stuff so much quicker. So that's my preference. You could definitely use the default general mode and just bump your exposure up or play with your laser settings. But this mode works for me, and this is what I'm gonna stick with. So go ahead and see if we can get it. Now I am wired this time. I'm not using the wireless connection, so let's just see if we can just pick up it. And you see the frame of reference, it's pretty large. I can pretty much see this entire part. Well, let's go ahead and kick this off. See, I'm already captured a good portion of this oil pump housing. Now this is the top half. This is the side that's actually exposed to the drive belts, or excuse me, your timing chain. The internal crevices is what we're going to be really working. So I'm going to use the zoom button. It's actually the bottom button on the scanner. I want to see if we can't get all this captured quite quickly. As you see, this is the reason why I like dark mode and black objects. If you can see, I can already see that I'm seeing those part numbers right now on the housing. I'm going to go ahead and try to chase all the yellow that I can, orange and yellow and all those not bright green. So they will capture quite quickly. And this is going to be uncut, so I'm going to actually do both sides. And if we miss somewhere and we need to go back, well, I'm just going to have to go back and try to capture this all in one go. I want to show you how easily you're able to capture technical parts, high detail parts, and go ahead and create you an STL file that you can start working with and trying to reverse engineer. So I'm going to take some time right now. This is quite important right now to do this edge, this leading edge, because I do have it elevated, but this is going to make it so much easier when we're trying to align the part. So take your time, always trying to do the overlapping edge. Overlaps are very important, and that's should be kind of your goal. You can always come back and fill in the details of what you missed, but the overlap is what you need to focus. Now, as you can see, we're getting in there pretty far with just the default scan settings right now. Yeah, I think that's enough. I think we actually have a good portion of the scan complete. I'm just going to review it quickly and see if I miss anything. Actually, I think I do have a bad spot right there. I think we have something blocking it. So where's that at? Okay, so it's on this back half right here. That's going to be really hard to hit, but let's try it. And notice I flipped the scanner on the side. And just do different orientation because you're going to try to introduce different angles of attack for the scanner. And I'm not using any. Oh, I stopped immediately because I already seen I messed up. I actually touched that. I think that's good enough for what we have. I don't want to introduce a bad scan. Okay, so that looks good. We can go ahead and complete. We're going to go ahead and do another scan. Now, this is where details matter. So, go ahead and put the part here. Probably and more basements. I want to try to be able to chop this out. So I want to make sure I'm not introducing junk that I can't remove. I need to be able to put down there in there. Takes this out. Put this guy right here and try to get into those crevices. Okay. Give it a quick spin to make sure I'm not going to touch anything. I already see that this is actually sticking out. I don't want to be able to accidentally bump it like I did with the last scan. It just needs to be centered more. Okay, I think we're good to go. Let's go ahead and do another scan. Okay. Make sure we can see markers. Looks like we got it all. And let's just go ahead and get going. This is where a laser scanner comes in handy with the accuracy. So remember, I don't have any markers on this part right now. I'm just scanning around it right now. Trying to stay in the excellent mode. I'm gonna go ahead and hit the zoom button so I can actually see what I'm doing. Remember, we're going to try to focus on that overlap. This is what's actually going to help us align the parts. Try to get in there nice and deep. We may be able to get that entire crevice if we're lucky, without having to use the single line mode or anything like that. Just default scan mode. Just being careful that I don't touch any of the like this. Since I don't have any markers on the part, walk it in from the side. I'm referencing these dots around it. Okay. As long as it can see markers in its frame of reference, you're good to go. I'm actually getting in there pretty deep into that crevice. Try to get into those gear rows. I'm going to introduce new extra angles of attack. Get in there nice and tight. If I'm getting most of that, come around this side. And I mean, you're really painting with a laser. We're just going to go ahead and fill this in. I see a little bit of area that I have not done at all. I'm going to focus on this. Okay. Now that's a real shiny part right there. Try to get into those crevices. Now remember, I have the scanner in or the part in a different orientation right now. So I'm going to take advantage of that and try to walk the scanner around. I'm introducing new angles every time. I'm trying to get as much point cloud data as possible. Try to see if I can get into the deep crevices. Okay. Now, I am going to try to use the single line mode after I've seen this a little bit. I'm just going to try to toy with it for a quick demonstration of what we're going to see. So, we get most of the scan done. Okay, kind of blocking that guy with this. That's kind of a bad placement. Hopefully I got most of that with the other scan. I think we did. Okay. All right, we're well over 10,000 frames. I'm going to go ahead and stop this. Okay. Make sure to exit out of your zoom. Now, I'm going to go to complete, but then I'm going to try to do something different. I'm going to go ahead and try to do single line mode. Okay, so yeah, we got a good bit. I'm not going to be able to get that overlap. Maybe if I had the part higher, raised it a little bit higher and planned out a little bit better, like maybe raised it onto that probably would have been a really good idea. Just using this lid might have got me the target I needed, but we're just going to go roll with what we got. So I'm actually going to change this to single line. Okay, now the laser actually turned into, should be single line. And then I'm going to go ahead and hit resume. Now again, it's personal preference on how you set up your scanner. I actually got this from Revopoint, one of their tutorials, but I bump up my brightness all the way on the laser itself. So this is full laser power, but I keep the exposure low. So now we should be able to get the zoom in. Should be able to get nice and deep into those crevices. Now, if you see it, it's only going to be painting one little line at a time. So I would not scan an entire part with this, but little areas you definitely can. So I'm going to try to focus on that area, maybe those crevices right there. Obviously, I didn't get into those crevices before. We're just trying to see if we can get a little bit more data. I'm going to focus quickly on every one of these holes. There's plenty of holes right here. Now you see it's starting to turn like greenish yellow. It's building up on top of that mesh. Okay. We're well over 15,000 frames. It's probably more than what I wanted to do, but I'm just demoing this capability. Okay. I think that's probably gonna be good. Focused on this hole, these holes. Just gonna make some passes on the part. Okay. So a single line mode. I'll set this guy down, exit out of zoom. And I mean, we did add data. You see it where it turned green, it's actually where it added data. So I got into here, I got into that area, I got into that area. I mean, you really need to spend your time with it. If you're doing one line, you're going from, I think, 15 lines down to one. So yes, of course, you're not going to capture as quickly. But you should be, see, I was able to get into that crevice. Still kind of screwed myself on this by putting this block right here. You know, let's try to do it this way. I'm going to go back to, I haven't stopped it, but I took that marker off. Let's see it. Now, if I see it trying to error out, I'll take it away. Let's just see. Yep. It's looking for that marker and it's not there, it's not seeing it, but we may be able to work around it. If you look on the screen, it still sees that triangle, so it found its spot. It's just now I don't have a triangle to reference. I'm referencing those triangles to the side, but you're very limited. It's really looking at these triangles. But I am going to do something. I'm going to hit complete. Now that I have that out, I'm going to try one more time with the parallel lines and just see if I can't walk it in and get as much data over here, because again, I had this blocking. Also, you're going to see how much quicker this captures and resumes. So let's see if we can't walk it in. Oh yeah, see, it recognized where it's at. And it's picking up that side very well. Now keep in mind, I'm already at like 20,000, almost 20,000 frames. So we're pretty deep into it. But since I know I need to hit some of these quickly back up, I'm going to go ahead and get as much data to those holes as possible. But you can see how many times you can still resume a scan, and it's going to color it from blue to green to fill in your data. Okay, I think that's enough. We're way past what I wanted to actually get done. So let's go ahead and hit complete. We're going to attempt to align these the way they are. We may be able to get lucky with just 2 scans. But I think we may need to do a third. But let's go ahead and do 2 things. I'm going to go ahead and do fusion. And I'm going to do batch process. So I'm going to do both of these at the same time. And we're going to just use 0.20. You can go even deeper, but for the video, and actually the cylinder head that I posted on like the Facebook forums is actually at 0.2. I did mesh at 8, but unless you're really trying to scan like a coin or something, there's really no reason why you want to mesh. I mean, I fuse really much smaller than 0.1. I mean, yeah, 0.1 or 0.15 or 0.2. I just prefer to choose with 0.2 because that's kind of a standardization. And if you're scanning a lot of large items, it adds up quickly. And I mean, the cylinder head was 2 scans, 21,000 and 21,000 or 22,000 frames. But that fused and meshed actually came out to about 2 gigs. So that's a large file, and I hope you have a lot of RAM to deal with that. But again, they give you the ability to actually fuse down to 0.05. And that's getting into like their mini scanner. The mini 1, mini 2 could do fusion points that small. And I mean, that's if that's what you need. But this is really more of a small-ish to medium-sized parts. I scanned the cylinder head, so I mean, we covered this area quite quickly. As long as you have markers, you're able to scan this quite easily, literally. So I'm hoping that. So this was a damaged part. This came off of my car. The oil pump gears started to wear into the casing. They're nice. They're very fine scratches, but they did wear into the case enough that it didn't merit a replacement housing. We were going to just replace it with foundry, like hardened gears, that could have reused the factory SVT case. But because this and the back plate that bolts on the back had wear, we completely replaced it to the 5.8 GT500 casings. But this is a nice piece of aluminum. Now, I probably could have spent more time in that hole. I'm pretty sure I didn't get that hole very well. For that, I would probably stand the part up like this and scan at an angle. But I mean, again, you do have single line mode, but you got to keep in mind it's still going to be working line of sight. So you have a big laser line, but you have two sensors that are about, well, we demo it right here. These two sensors are still 4 inches apart, so they're pointed in this focal range basically amongst each other. So you're only going to be able to pinpoint to a certain area because this casing is blocking. If this part of the case wasn't available, then yeah, you can absolutely probably shoot down there and scan that, no problem. I do believe we got lucky and was able to scan both radiuses there. There's a step down right here. I'm hoping we captured that, but if we didn't, I mean, again, that's something that if that data is useful for you, most people will take that step down with a Dremel and actually increase the flow from there. That actually is just bad casting design, because your pickup tube bolts here. There's an O-ring and there's a pickup tube that bolts up. So there, it makes no reason for that to be a stop there. There's a little deep edge. Um, and now I'm kind of kicking myself for not actually doing that on the replacing housing, but because I didn't think it was that bad. When you're working on the vehicle and you're swapping in your gears, you're kind of not really paying attention to this. And plus, you didn't want to introduce new dust or debris. So this was still plugged off, and this housing was removed. Oil pumps were slammed in, packed with assembly lube and everything. But so it makes sense. But now I'm seeing that, and that would have been an easy modification. But anyway, this one lasted 70,000 miles and over 407 track passes. So the thing's been to hell and back, and I never lost oil pressure, so that's good. All right, so this one should be the 21,000 frames. So this one's going to take the longest. So let's just go ahead and let it finish. The 10,000 frame ones, the first one that was on this side, I don't think it's going to take that quite long. So we're going to try to fuse them. Fuse, do a quick cleanup, then merge them, and then after that, we should just be able to see what the results are. Okay. Now, some people don't like that I don't cut the videos, but some people do. I personally believe I shouldn't cut the videos and speed it up because I don't want you to have a false sense of how long these take. I've seen a lot of these videos where people will scan this and show like 30 seconds and then they click a button and it fuses and meshes in 20 seconds. I think that's false sense of expectations because this is a pretty high-end laptop. This is a 1490 i9, 64 gigs of RAM, and an RTX 4070, and 2 terabyte SSD. So it's a stout laptop. Now, granted, it's long in the tooth. It's almost a year and a half old. Not the latest tech, but keep that in mind when you're specking out hardware. So you just bought an expensive scanner, you need to have it backed up with something else than a 5-year-old laptop that you bought from the garage sale. You need to actually invest in a stout computer. That's very important. I stress that because the company is trying to make lower performance systems more compatible, and actually be able to scan easier on their older equipment. Yes, that sounds great in theory, but it kind of punishes people that have high-end systems. I honestly think high-end systems should be the standard. You should at least have an RTX 4060, should be an i9. You should have at least 32 gigs of RAM because we need to be able to mesh quicker. We need to be able to process quicker. So this delay probably could be a lot quicker that we're waiting on right now, that it's taking 3 or 4 minutes just to fuse. If you let this processor eat, I'm willing to bet it's only, I can't share the screen. I got OBS scan for this window only, but task manager only says my CPU is at 11%. So, and my RAM usages right now is only 19. So, I mean, it's it's really not working yet right now. 20, I'm at 20 gigs now. So 20 gigs of RAM and 11% CPU. That tells me that all of my 30, I think it's 32 cores are not working. So when they tried to make it faster for someone that's got a 10-year-old laptop and is just trying to struggle to work, yes, that makes sense. But if you have a high-end system, we're being punished for all the people that are trying to use like lower-end systems. So just keep that in mind. Let's get a trend of everybody going to a higher-end laptops. So we're not asking for it to be slower. We're making it as quickly as possible. I would like this being, pegging 60%, 70%, and this thing scans at 60 frames, 70 frames per second. We're we don't have to throttle for compatibility. We can just make it eat and we'll make it work. Um, the older software that didn't rely on GPUs, where didn't really have to manage, expectations for, GPU performance, PC performance, like back uh, Revel, Revel Scan or Revel Studio, like 2.0, whatever. If you had a high-end laptop, I literally could click. It would say 2 minutes of process, and it'd be done in like 30 seconds because you had a high-end system. So, all right. Well, I'm done talking. Let's go ahead and see what we're looking at right now. Okay. So, all right. That looks pretty good. I mean, look at the part numbers. I mean, okay. I think that works pretty good. Okay. All right, so on this basis, I'm going to do two things. I'm going to go ahead and do a nice shortcut that I like to do is I'm going to go and clip this plane. Because it's elevated, I know I safely can do this. Got the wrong side, I'm going to go ahead and flip that. Delete this. Okay, now I'm going to escape that. Now we see our parts just kind of floating in the air. Now we should come over here and do isolation and quickly do default. If it takes too much stuff out, we're going to reverse it, but it looks like it's targeting the right stuff. Okay, you apply to that. Do it again. It should pick up those other guys. It did not, so I'm gonna do that, that, and I'm going as fast as I can. I mean, if I was taking my time, I would probably look over. Oh, sorry. You know what? I screwed up. I was supposed to hit delete. Okay. Hit delete. Okay. Do isolation one more time and make sure I don't have any floaters. It doesn't. If you give it that little error prompt, that means you're at a good stopping point. So let's just do a quick overlap. Found something. Tagged again. Something. Overlap. Okay, got an error. We should stop there. Let's go to this other guy. Okay. Same deal. We know it's elevated, so I can go ahead and clip this. I'm going to try to be as level as possible, but I'm going to clip this. Okay. Flip it. Delete it. Okay. Oh, escape. Escape. Okay, see, it's floating by itself. Now, this one's going to be a little bit more tricky because I do have those other floaters, but let's go ahead and see if isolation picks up those. Okay, picked up a good bit. Okay, same deal. We're gonna have to chase this guy, chase this guy, chase this guy. Okay, now let's go ahead and see if we can't find. Okay, so it's just one. That should be very easy to clip out. So we're going to find something that doesn't have a case. I'm just going to try to see if I can't chop this off as close to that plane as possible. Without cutting too much of that part off. Okay, hit delete. Okay, do isolation. Didn't find anything. Let's do overlap. Now little guys. Text. Okay, so now we have our part. Well, see, we did get in there pretty well. And you can see that step that I was talking about. You can see that's oil galley, well, excuse me, gasket galley. I did get in there. I got into there. I did get into that hole pretty well. Okay. You can also see some threads in these holes right here. I mean, so it's not useless data. So make sure I don't have any other scan aids in the frame. Okay. So now we're going to go ahead and merge. And we're just going to see if dumb luck that our feature alignment picks up. And I guess we got dumb luck because that looks complete to me. I don't know about you, but that looks pretty complete to me. Now there is some little bit of holes. Again, I didn't get that guy, and that was my fault because I had one of these blocking the line of sight. So just keep that in mind. But we're gonna do two things. We're gonna generate that model. Now it's very important. Now that I know that we have pretty much a complete scan, the model looks pretty complete. I don't see many stragglers. I need to go back. Like there's not a section that I need to go and hit up again. I'm fine with that. And again, if I was reverse engineering, I wouldn't really care about that bolt hole. I'd be more about this flange, and we captured that flange completely fine. We captured that flange, captured that flange, and then the back plate flange. So we should be golden. Also all the bolt holes. So I think we're good. And this is very important. This is to align your sprocket. So if you got that off, then you could have sprocket issues. So I don't see we have any holes, so I'm going to go ahead and go into Fusion. But what I want to stress, please, when you're done scanning, disconnect this guy. Don't leave it plugged in. Don't leave it on a table. Ask me how I know. These things are slippery. I know you're supposed to, you can stand it up on its side. I mean, you can over here. I will say now that they have more of aggressive like arc between them. This is a little bit more top heavy than the Metro X. Metro X was kind of like a big blocky square, so it stood on its side. I mean, upright a lot better. Take it down, put it in your box. Put it in case, leave it alone. That way you don't have to throw anything to worry about. Okay, so we have our completed merge. Okay, so now we're going to do isolation. So we got some stragglers. We'll bump this up a little bit more. Didn't see anything. Reset it. Text. Okay, didn't see anything. Now we're going to do overlap. Now overlap's going to come into more play now because you're aligning parts. So now keep in mind, these are still point clouds. That's how dense these point clouds are. This is not a mesh yet, but if you look, they're very uniform. So you're building good point cloud data and accurate point cloud data. That's what I want to stress. Okay, so I'm going to do overlap one more time. Okay, did pick up something. We'll bump it up a little bit more. Pick up some more. Yes, it's kind of random. I just keep going until it keeps finding stuff. Keep it applying until I get that nice little prompt from the side that says I can't find nothing. Hit again. Text. And all this is doing is reducing noise. You'll have floaters everywhere. Remember, these are still points. There's nothing complete about this. I want to see. Yeah, there is some flashing on the sides. I want to make sure that that's not bad scan. There is like flashing from cast aluminum on the sides right here that I'm seeing. There's a little bit of a monk. And that's a dirty part. I quickly wiped it down, but it's not. Yeah, it's got these teeth pretty well golden. Okay, so all right, so I can't remember if I saw that error. We do have one little hole right here that needs to be filled in. That's right there. I want to point out. I forgot about it. I think I tried targeting it with the single lock, but that is way. I mean, it's literally pointless. Like so. I mean, I mean, that's deep, and that kind of makes pointless. It should have been filled in with aluminum. That makes no sense to be cast in like that, but whatever. So that's one thing you can definitely fault me that I could have probably focused a little bit more. All right, so we're gonna mesh. We're gonna high quality mesh. We're gonna go full send. I'm gonna do enable full hole filling, but I am gonna only fill in. I like to only fill in like 2%. Um, it's a little bit more aggressive for my liking. Maybe 5%. Let's just do 5. Default's like, I think, what is default? 30%. Yeah, no, I don't like that. I mean, you can. Looks to be a pretty watertight model, but I don't like it when it fills in too much holes. I think it just adds artificial junk. I don't want to do that. For me to do CAD work, I don't care if there's a hole there. In fact, I'd rather there be a hole there. At least it's not artificial. I know that that's a bad area if I'm referencing a hole or if I'm referencing a plane. I'm just going to completely skip that area or focus around it. I may do hole fill within the application, but yeah, I'm not going to do anything else. Now that I know that these scans were able to merge quickly, and if this doesn't get enough details for me, remember I fused at 0.20. I can fuse at 0.05. So then you would probably pick up the casting rough etchings. You would just pick up a lot of, but you would also have to do a lot more cleanup. You're going to introduce a little bit more noise. This is actually taking, you know, generally a little bit softer point cloud alignment. Um, it's only going to focus on point clouds that are 0.2 millimeters distance. Everything else is going to toss out. If you do 0.05, that's going to be a smaller gap. And if you did not get that bright green, you might have just got a little green, then it may not be very accurate, or not, excuse me, it may not be complete mesh. It may not be able to fill that void. So then you may actually get a noisy spot. Now, if you saw when I was scanning it, I selected black mode, but I used the default black mode, which I think is 0.4 millimeters. So when it was coloring in green, it was coloring green with the accuracy of 0.4 millimeters. Okay. So keep that in mind. If I needed it to be a 0.1 millimeter fusion scan, I should have turned it to 0.1 millimeter 0.1 millimeter capture display. So that way I would have had to sit here. It would have stayed blue a lot longer and would have took forever to turn green, but it would have been accurate data. All right, cool. I think we're golden. So that water pump. So I'm gonna go ahead and maximize the screen. I don't know about y'all, but I think that looks pretty good. So we have the castings, we have the part number. Yeah. I mean, I can clearly see those part numbers. So Looks right to me. Lot 10. Yeah. We got Ford stampings there. Now there is some small like pin etchings here. It says SVT. Looks like they're stenciled in. That looks like I probably would have needed to do a fusion at 0.1. But I mean, for what I need it for, I bet you we could probably see if we get the light just right. No, the fusion's a little bit too small, but I mean, yeah, I think that's a golden. See, it filled that hole. I don't like. I probably would have done my default 2%, and that hole would have been perfectly fine. For me to reverse engineer it, it would have been fine because I'm going to focus on this area and probably like mesh down a little bit. But now this is completely fine. Okay, well, that is the complete scan of a GT500. It says 3-valve. I do not know why it says 3-valve. I guess it fits the 3-valve motors too, but this is actually a GT500 oil pump. So it fits 5.4s and 5.8s. But I don't know about y'all, but that looks to be a nice, complete scan. Okay. Well, I won't waste any more of your time. This has been SkreetKar 3D. Hope you enjoyed the scanning. Hope you learned something. I'm hoping you'll be able to use my methods for your use cases. If not, I mean, these techniques could technically be applied to all scanners, laser scanners for this purpose, but if it's a structured light, if you have marker mode, you're still going to be doing the same process. But again, Sam Willie from SkreetKar 3D. Hopefully you enjoyed the video. If you want to follow some more, just subscribe. I'm gonna have a Revopoint section of just for future scans and future tweaks. I also did the Track It scanner, which scans larger vehicles like this Mustang right here. But as long as they keep sending me scanners to test, I'll keep doing it. I'll actually be at the SEMA booth November 4th through 7th. So if you want to actually have hands-on experience with these scanners, please come see me at the SEMA booth. And I'll put one of these scanners in your hand. You can demo it, see whatever you want to do, and I'll tell you what you're doing wrong, what you're doing right, and we'll just adjust. And yeah, if you have a part that you want to have scanned, bring it to the booth. We'll scan the mess out of it. Anyways, y'all have a great night. Thanks.